In this video, let us understand the properties of arcs. The properties of arcs which we will discuss in this video are relationship between angles subtended by a chord at the center and elsewhere on the circle, and other properties which are derived from this property are property of angle inscribed in a semicircle, property of angles inscribed in the same segment of the circle, condition for four non-collinear points to be concyclic. Now let's take these properties one by one. According to the first property, angle subtended by an arc at the center of the circle is twice the angle subtended by it on the remaining part of the circle. So if we suppose that this is center O and this is the arc which we are considering, let's call it as arc AB. This arc AB subtends at the center angle AOB and subtends angle APB on the remaining part of the circle. According to this property, the central angle is twice this angle which is subtended on the remaining part of the circle. Next, let's see the property of angle inscribed in a semicircle. If the solid arc here is a semicircle, then the angle inscribed in it, that means this angle and this angle, will be 90 degrees. And the reason for this is simple. If we consider this dotted arc, then if this is the center, then central angle for the dotted arc is 180 degrees, and these two angles are the angles inscribed by this arc on the remaining part of the circle. And we know that these angles will be half of this, as we have discussed in the first property, so these angles are 90 degrees each. In the second figure also, this is the semicircle, and angle inscribed in the semicircle will be 90 degrees. The converse of this is also true. If in an arc of circle, angle inscribed is 90 degrees, then the arc is a semicircle. Next, we discuss the property of angles inscribed in the same segment of the circle. So we can see here that these angles are inscribed in the same segment of the circle. The measures of such angles will be equal. The next property is condition for four non-collinear points to be concyclic. So if we have AB as a line segment and it subtends equal angles at point C and D, then these 4 points A, B, C, D are concyclic. That means they will lie on the same circle. Converse of this is also true. That means if these 4 points lie on the same circle, let's draw a circle, and my circle here is not exactly a circle, but you can consider it to be a circle. If these 4 points are lying on the same circle, then these angles will be equal. Let's summarize what we have learned in this video. We've learned the property that the angle subtended by an arc at the center is twice the angle subtended by it on any other point in the remaining part of the circle. And we also learned the properties derived from it. We learned that angle in a semicircle is 90 degrees. Angles in the same segment of a circle are equal. We also learned the condition for non-collinear points to be concyclic.